Polynomial inequalities. To solve a nonlinear inequality where f of x is less than 0, f of x is greater than 0, f of x is less than or equal to 0, or f of x is greater than or equal to 0, we have to rearrange the terms of the inequality so that one side is set to 0. Find the solutions of the related equation f of x equals 0 and any values of x that make f of x undefined. These are boundary points for the solution set to the inequality. In calculus, we call this partition points. So usually they're the same thing, but depending on the book, just different terminology. Draw a number line with the boundary points indicated with either closed circles for less than or equal, or greater than or equal, or open circles for less than or greater than inequalities. Determine the sign of f of x. F of x is y on the intervals defined by the boundary points. If f of x or y is positive, then the values of x on the interval are solutions for f of x greater than 0, because positive values are greater than 0. If f of x is negative, then the values of x on the interval are solutions to f of x less than 0, because negative values are less than 0. So in the following problems, they want us to determine whether the boundary points are included in the solution set. Well, first we need to solve for x. We'll get everything over to one side. And for a moment, I'm going to set this equal to 0 to find those boundary points. This is one of those nice kind. The numbers I need, I believe, are 5 and 3, and I need a -5 and a +3. Set that equal to 0. And that's what this particular graph is illustrating. But let me do my number line. I'm going to have -3 here. I'm going to have 5 here. Now, my y values to this side of that 0, notice my y's are above the x-axis. They would be positive. Between -3 and 5, y values are below. After 5, they're above again. Now, the inequality I'm going to be looking at is this one, when everything's over to one side. So for this side to be less than or equal to 0, first, less than or equal, these are solid dots. This needs to be negative, and the only section I've got negative is that one right there. So interval notation. So that would be the answer for that particular problem. In this problem, let's see, this has multiplicity of 2. Notice it touches and goes back up. This has multiplicity of 1. It crosses. So it's already factored. I'll go ahead and do my number line on this one. I've got x is -3, x is 2. This has to be open. So to this side, on this side of -3, my y values are below. So that is negative. Between -3 and 2, they are above. After 2, my y values are above. Now, in order for this side to be greater than 0, this side's going to have to be positive. So I've got this section and that section. But now, guys, this is not an or equal. For me to write my solution as an interval notation, I have to exclude 2, because if I substituted 2 in, this would be 0, and 0 is not greater than 0. So that's it for this particular piece right here. Next page is very similar.